just a quick one on the turntable hub. I'm just about to install two bearings into the hub assembly. So this is just come off the printer. I've just threaded out the 4 holes here, so they are M2s. The centre hole is 8mm with a recess hole of 9.5mm diameter and recess 1.2mm down, and that's to accept the bearings. So I've got a 3mm ID, 8mm OD, and they're 4mm deep. This one is the same, 3mm ID, 8mm OD, but it's got a shoulder on it, and that is 9.5mm, and it's 1mm in depth. Okay, let's got those in, so they're a nice push fit in. So we've got it installed. That's the bottom one, and the top one's installed as well. Okay, so here we have the fresh off the printer is one of the substructures on the dumper. So this goes in the front end, and it houses the switches, the limit switches for the turntable, the center pin for the turntable, mounting brackets for the servo motor, which is going to be driving the turntable around, and also the axle mount. Need to run a tap down, threading tap at 1.6 for these holes here, which the limit switches will be screwed down onto, and the center pin's got to be tapped out as well. So eventually this will fit, well, first of all it will fit on the front axle. It'll be screwed onto there, but it also attaches the front axle onto what would be the outer casing. So there's a lot of work going on inside here, a lot of cutting out, and basically I'm just using the outer shell to house it all in. Now that we've got the bearings installed into the turntable, the next part in the line of it all is this bit here. So this is, I suppose you could call it a camshaft. It will rub up against the limit switch, so the limit switches, so it will restrict the movement of the turntable. I'm aiming for a 90-degree turn each way for the turntable, but I've got to line everything up. So what I'm going to do is, if I put the gear on there, that's in its correct position, then I'm going to put this, which is the drive gear, and that has got to line up exactly with the camshaft. So it can only go one way in this instance because I've got countersunk holes in, and that is so that these little 1.6mm screws will sit flush on the gear, so give us a flat surface to work from. We need to place that onto the camshaft, then use an M3 screw just to line everything up, like so, and then turn that around until the screw holes line up, and then we can screw those two components together. Got the gear screwed onto the camshaft now, and if I just hold it to the side, that's how it will eventually sit. So I can take this center pin out, and that will come out. So that's the two components lined up, and the next bit will be to install this into the mounting plate, the mounting bracket, which is over here. That gear will sit on the center pin, then the limit switches will go on, and that is designed to operate the limit switch when it's reached 90 degrees. So that will go around and contact the limit switch. I've used a 3.7G servo motor, and I've taken out the position sensor and just literally wired it across to the motor, and I don't know whether you can actually see through the housing, but it's just a straight through connection. I couldn't use it as a 180 servo because it's geared. It's a worm and gear drive reduction, and a 180 turn on the output spindle won't give you 180 on the output. So that's the reason why I've taken the position sensor assembly out of the servo. I also bored the output shaft of the motor 3mm and set in a 3mm stainless steel pin, and done a push fit on the worm drive gear. So this is not standard, it's a custom build to get this sorted. Got the limit switches mounted here, and I've just temporarily wired it through the switches just to make sure everything works in the right direction. We've got servo motor driving a worm gear. The worm gear drives the other gear, or the driven gear. This hub with a cam lobe on it is attached by two screws down underneath, and then the limit switches, I've got left and right limit switches, and they're bridged across using the diodes. Once this is in the housing and the axle is screwed down underneath, then this hub will fit down through the housing and engage into the hex. So I've got that the wrong way around, that should go that way around. That will engage onto the hex like that. Then mounted on top of the turntable will be the bracket that holds the skip and the skip motor. That's going to be screwed down through, so that'll all be as one. Here's the joystick. So by going left or right, the little wheel is turning left and right as well. Now if I push this to its extent and hold it, it automatically cuts out, so there's nothing I can do. I can't go any further right now, so the only way to back it out is to pull it to the left and it will reverse. As soon as the switch is open again, the diode is bypassed and I've got the forward and back available, but as soon as that switch is triggered, it won't do anything. So I can take that all the way round now to the switch on the other side, and anywhere in that range I've got the backwards and forwards response. But if I pull and hold that now, we'll see the right hand switch trigger, and I've still got the joystick holding on to the joystick, so there's no more turning to the left. The only thing I've got available now is to go forward, turning to the right, and as soon as I've done that, it opens the switch, and I've got the two-way response. So that's basically how it works. So it's pretty much foolproof. So what you're doing is you're isolating it electronically rather than stalling the motor. It's never a good idea to stall the motor. So that's the way of doing it, by using 2 limit switches and 2 diodes. So the test today really was to make sure that I got the diodes the right way round. Because if one of those was wrong, or the feed was reversed, so the input and the output, if you like, on the switch, if that was reversed, it wouldn't work, or it'd only work one way and you couldn't reverse it, all sorts of things. So the only way of knowing for sure that it's right is to get it to respond like that.